Chapter 2, Atoms. In this chapter, we will examine the close link between atoms, the particles within the atoms, and light. Atoms are the basis for everything. All matter is composed of atoms. Everything that we touch, we taste, we smell, and we see. Even our human body are made of atoms. Atoms cannot be broken down by chemical or physical means, except by nuclear reaction. There are three types of particles in an atom. The positively charged particles are called protons, the negatively charged particles are called electrons, and the neutral particles are called the neutrons. An atom is charge neutral. It has no net charge, meaning that the number of positively charged particles equals to the number of negatively charged particles, or simply just as the number of protons equal to the number of electrons. There are 118 known different types of atoms. These different types of atoms are known as elements. We can simply say that there are 118 known different elements. Each element has a unique name and corresponding atomic symbol. The atomic symbol contains one or two letters. For example, carbon has an atomic symbol as a capital letter C. Neon has the atomic symbol as Ne. All atoms share a common structure, a dense, positively charged nucleus. Inside the nucleus, you will find the positively charged proton and the neutral neutrons. The protons and neutrons all together only take up a small portion of the volume of an atom. The nucleus itself is surrounded by a cloud-like smear of negatively charged electrons. Although electrons take up an enormous amount of spaces, but they only contribute a fraction of the mass of an atom. It is a very insignificant portion of the mass of the atom. Later, we will learn about the mass number, which only considers the mass of protons and the neutrons. Just for your information, a proton or a neutron is about 2,000 times more massive than an electron. Imagine that you draw a line from San Francisco to Washington, D.C. as the diameter of a circle. The atom is the circle drawn over North America as shown on the picture. The size of the nucleus is simply the size of a grocery store. Hopefully, this analogy gave you an idea of how tiny the nucleus is compared to the size of the atom. From the inside cover of your textbook, you will find a periodic table. In each of the cells, it is an element. You're going to see a whole number usually listed on the very top of each of these elements. They are called atomic numbers. The atomic number of an atom is equal to the number of protons the atom contains. For example, if you have hydrogen here, its atomic number is 1, therefore it has 1 proton. The next one is a lithium. Lithium has atomic number of 3, so it contains 3 protons. Or calcium. Calcium atomic number is 20, so it contains 20 protons. Try to recall from the previous slides that an atom has no net charge. It is a charge neutral. Therefore, the number of protons in an atom equals to the number of electrons. For example, the lithium that given to you to the right has 3 protons and 3 electrons. The 3 positively charged protons and the 3 negatively charged electrons cancel each other out will give you a net zero charge. Most lithium atoms contain 4 neutrons, although some contain 3 neutrons. We'll talk more about the isotope of atoms later in the chapter. The periodic table originally developed by a Russian chemist, Dmitry Mendeleev. The horizontal rows are known as periods. The vertical columns are known as groups or families. There are 7 periods and 18 groups in the periodic table. As we move left to right across the periodic table, the number of protons increases, so does electrons. The lactinized and actinized family do not fit nicely into the main part of the periodic table. They are placed at the bottom of the table. The first 92 elements are found naturally. Anything after are artificial. These man-made atoms are created in specialized laboratories. Element 113, nihonium, was confirmed in 2016. Element 118, organescent, is the highest atomic number element to have an official name at this time. The number of protons plus neutrons is the mass number of an element. The mass number is written either as a superscript or after the element name. The element below is called chlorine-37. Different atoms of the same element can have different numbers of neutrons. Isotopes are the atoms that have the same number of electrons, the same number of protons, but different numbers of neutrons. If you know the mass number of an element, you can simply solve the number of neutrons by subtracting the number of protons from the mass number. If you use letter X to represent an element, and letter A on the upper left corner is the mass number. Recall that the mass number is the sum of the number of protons plus the number of neutrons. Okay? And then on the lower left corner, we're using letter Z to represent the number of protons. The number of protons is the same as the atomic number from your periodic table. Let's take a look at these two isotopes, titanium-48 and titanium-50, as an example. First of all, the titanium-48, the number 48 is the mass number written on the upper left corner. Okay? And then on the lower left corner, number 22 represents its 22 protons. You can find these 22 as the atomic number from the periodic table. Okay? Once you know the mass number, you also know the number of protons. You can simply subtract this number, 48 minus 22, to get 26 neutrons for titanium-48. On the other hand, the isotope of that element, titanium-50, you have a mass number of 50, the same number of protons. Okay, same element will have the same number of protons, 22 right here. Then you can simply subtract 22 from 50 to give you 28 neutrons. Recall the definition of isotope. Same number of protons, 22 for both. Same number of electrons, 22, although it's not on the slides, but protons are positively charged. Since they're neutral, you will have 22 electrons, but different number of neutrons. One is 26 neutrons on the left, and then 28 neutrons on the right. Why neutrons matter? Different isotopes of an element has different natural abundance. Isotope ratios are used in carbon dating, a method to determine the age of something that was once alive. The atomic mass is the average atomic mass with considering all different isotopes of an element. For example, chlorine atomic mass is 35.45. It is actually coming from chlorine-35 and chlorine-37. In nature, they are 75.77% chlorine-35 and then 24.23% of chlorine-37, and then these will average out to have an average atomic mass of 35.45. Same thing is true for carbon, with an average atomic mass of 12.01 coming from 98.92% carbon-12, 1.078% carbon-13, and a very, very trace amount of carbon-14. Different elements will have different number of isotopes. For example, like calcium will have a whole lot more isotopes than carbon and chlorine. If you move on to tin, there are like 10 different isotopes for tin. All isotopes of an element will usually react in the same way chemically. Isotopic percentages of the atoms in a sample of matter can be used for things such as carbon dating, forensic analysis, identification of the origin of a sample of matter. After protons and neutron discussion, now we move on to the discussion of electrons, the most important particle for chemists. It is involved in chemical reactions. Electrons occupy different areas of space around the nucleus. The furthest away the electrons are from the nucleus, the most likely the electron to be involved in a chemical reaction. Recall that electrons occupy a huge space around the nucleus, so it is very hard to pinpoint the exact location of an electron. The diagram on the right-hand side shows the structure of an atom. At the center is the nucleus. It contains neutrons and positively charged protons and gives an overall positively charged nucleus. The shaded blue area around the nucleus represents the space occupied by the electron clouds. The electrons are quantized and placed in different energy levels. The first energy level is the level closest to the nucleus and has the lowest energy. As we move away from the nucleus, each level after will have higher energy. At level 1, it is capable of holding 2 electrons. At level 2, it can hold 8 electrons. And at level 3 will be 18, and at level 4 will be 32. The location of an electron with respect to the nucleus determines its role in the atom. The further an electron is from the nucleus, the more loosely it is held by the nucleus. The outermost electrons are involved in a chemical reaction. The layered arrangement of electrons in an atom is merely a model scientists have developed to visualize the atom. Electrons do not stay in fixed orbits around the nucleus. The lowest energy level of a particular electron is the ground state. In contrast, when an electron is energized, it moves to a higher energy level, excited state. When electricity, the energy is applied to atoms in a lamp, the electrons become energized and move to a higher energy level. As electrons relax, they give off energy in form of light. As you can see in this diagram, as electrons absorb energy, it will jump from the ground state to the excited state. And then it will fall back down to the ground state and give off energy as a form of light. It is not necessarily to jump from level 1 to level 2. If you have sufficient energy, it could jump from level 1 directly into level 4 or 5. Same thing is true when it relaxes, come back to the ground state. The type of light that is given off depends on the difference in energy between the energy levels. The different types of light are represented on the electromagnetic spectrum. The visible light region is the only narrow region on the spectrum that our human eye are sensitive to. As you can see from the left-hand side, we have gamma ray, X-ray, ultraviolet light, and then the visible regions start from purple, blue, yellow, red, and then continue to infrared, microwave, and then radio wave. And then down below, as you can see that the frequencies are much stronger at gamma ray side of the spectrum compared with the radio wave area. So we're going to say that the radio wave have a longer wavelength than the gamma ray waves. And however, the gamma ray waves will have a higher frequency compared with the radio frequency. What is the wavelength? A wavelength is defined as the distance from one peak to the next of a wave. How about frequency? The frequency is the number of waves that passes a point in space during any time interval, usually in 1 second. Shorter wavelengths of light are more energetic than longer wavelengths of light. In another word, the higher the frequency of a light, the more energetic it is. A 400 nanometer light is more energetic than a 750 nanometer of light. Wavelengths is usually measured in nanometer. Recall from chapter 1, 1 meter is equal to 10 to the 9th power of a nanometer. Sunlight includes all the colors of visible spectrum in addition to light from other regions of the electromagnetic spectrum. To summarize what we learned so far, the longer the wavelength, the lower the frequency, and then the less energy it is. On the other hand, the shorter the wavelength, the higher the frequency, the more energetic the light is. A line spectrum is a pattern of lines of light that is characteristic of a given element. Excited atoms of a specific element give off specific wavelengths of light that correspond to the spacing between energy levels of atoms of that element. These specific wavelengths of light are known as a line spectrum. Below is the line spectrum of sodium. We can use a line spectrum to determine what elements are present in a given sample. Let's take a look at some of the questions. Question 1. What is the positively charged particle in the nucleus? A. Electron. B. Proton. C. Atom. D. Neutron. This is more of a definition question. I'll give you 10 seconds to think about it. You feel free to pause here. The correct answer is B. Proton. Question number 2. How many protons are in a magnesium atom? A. 12. B. 10. C. 24. D. 2. You would need to have a periodic table to work this question out. Please pause here. The correct answer for this question is A. 12. From your periodic table, you first find the magnesium. Magnesium have a symbol Mg. It is on the 3rd period in group 2. The atomic number says 12. The atomic number tells you how many protons are there. Therefore, there are 12 protons in a magnesium atom. Question number 3. What is the name and the element symbol for the element that has the atomic number 16? A. Oxygen, OX. B. Oxygen, O. C. Sulfur, S. D. Sulfur, SU. You would also need a periodic table for this question. Please pause your video here. The correct answer is C. Sulfur. Sulfur is located at group 16, period 3, with the symbol S for sulfur. Question number 4. Which element is in group 14? A. F for fluorine. B. C for carbon. C. N for nitrogen. D. O for oxygen. Again, you will need your periodic table for this question. Please pause your video here. The correct answer is B. C for carbon. Carbon is a group 14 element, and your choice A, fluorine, is in group 17. Your choice C, nitrogen, is a group 15 element, and then your choice D, oxygen, is in group 16. Only choice B, carbon, is in group 14. How many protons, neutrons, and electrons are in the copper-64 isotope? A. 35 protons, 29 neutrons, and 35 electrons. B. 29 protons, 64 neutrons, 29 electrons. C. 29 protons, 35 neutrons, 29 electrons. D. 64 protons, 29 neutrons, and 64 electrons. Please pause your video here. The correct answer is choice C, 29 protons, 35 neutrons, and 29 electrons. How do you do this problem? You will need your periodic table first. You first going to locate copper. Copper have a element symbol of Cu. It is located at group 11 on the very top. So when you locate copper, you will see the atomic number of 29. Atomic number, it is the same as protons. Therefore, you know that you have 29 protons. And then, because an atom is a neutral charge, protons are positively charged. Therefore, you need to have the same number of negatively charged electrons to balance it. So you will have 29, the same number of electrons. From the question, it's telling you that it is copper 64. The 64 is the mass number. Try to recall the definition of a mass number. Mass number is equal to the sum of protons and neutrons. So if you need to solve for neutrons, you just have to take the mass number 64, subtract the number of protons to get to the correct number of neutrons, which is 35 for this question. Question 6. Which electrons are involved in chemical reactions? A. All of the electrons are involved in chemical reactions. B. Electrons are not involved in chemical reactions. C. The electrons closest to the nucleus are involved in chemical reactions. And D. The electrons furthest from the nucleus are involved in chemical reactions. Please pause your video here. The correct answer for this question is D. The electrons furthest from the nucleus are involved in a chemical reaction. These outermost electrons are very loosely held by the nucleus. They are likely to be gained or loose or shared in a chemical reaction. Question 7. Which type of electromagnetic energy has the longest wavelength? A. Visible. B. Ultraviolet. C. Infrared. D. Microwaves. Please pause your video here. The correct answer is choice D, microwaves. To answer this question, please refer back to the electromagnetic spectrum in the earlier slides. Question number 8. Which type of visible light has the highest energy? A. Violet light with a wavelength of 400 nanometer has the highest energy. B. Yellow light with a wavelength of 660 nanometer has the highest energy. C. Blue light with a wavelength of 550 nanometer has the highest energy. D. Orange light with a wavelength of 700 nanometer has the highest energy. Please pause your video. The correct answer is violet light with a wavelength of 400 nanometer has the highest energy. You may not remember the exact order of these visible lights in the electromagnetic spectrum. However, you can simply just look at the wavelengths of each light. Recall that the shortest wavelengths, the higher the frequency, the higher the energy. So you can simply compare the 400 nanometer, 660 nanometer, 550 nanometer, and the 700 nanometer. Find the smallest number, 400 nanometer. It is the shortest in wavelengths. It is the highest in frequency out of 4, therefore it is the highest in energy. Question number 9, fill in the blanks. When an electron in an atom blank a photon at a specific blank of light, the electron can be pumped to a higher energy level. When the electron returns to the ground state, the electron in an atom blank a photon, often in the form of light. Choice A, emits, wavelength, absorbs. B, absorbs, wavelength, emits. C, absorbs, emits, wavelength. D, emits, absorbs, wavelength. Please pause your video here. The correct answer is B, absorbs, wavelength, and emits. The electron absorbs energy at a specific wavelength of light so that it can jump from the ground state to the higher energy level excited state. Upon it return to the ground state, the electron releases energy or emits energy, often in the form of light. Question number 10. Imagine an atom of sodium with electron energy levels around the nucleus. What is the correct number of electrons in each energy level for sodium? A, there are 2 electrons in level 1, 18 electrons in level 2, and 8 electrons in level 3. B, 2 electrons in level 1, 9 electrons in level 2, 0 electrons in level 3. C, 2 electrons in level 1, 8 electrons in level 2, and 18 electrons in level 3. D, 2 electrons in level 1, 8 electrons in level 2, and 1 electron in level 3. Please pause your video here. The correct answer is choice D. There are 2 electrons in level 1, 8 electrons in level 2, and 1 electron in level 3. Hopefully the diagram on the right hand side gave you some good clue. As you can see in here, at level 1, it could only hold up to 8 electrons maximum. At level 2, it could only hold up to 8 electrons maximum. At level number 3 and level number 4, it could hold 18 and 32 respectively. So, you're first going to locate sodium in your periodic table. You can find this is atomic number 11. It's a sodium. So, that tells you sodium has 11 protons and 11 electrons. Next, you're going to place 2 electrons into your level 1, and then place 8 into level 2. You only have 1 more electrons to go out of the 11, so you're going to place it in level 3. That will give you the correct choice as D.